Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 64 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Raphael kit for Raspberry Pi. Now, most of you guys probably already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon. You can hop on over there and pick up your kit. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how to bust into that data set that is returned from Tensorflow when we're doing object detection, and how to take that big gnarly data structure that is returned and break it out and get the useful information that we want. Sound pretty neat? I hope it does. Now, I don't want to start completely from scratch, and so what we're going to do is we're going to start with the code that we developed in lesson number 63. That was last week's lesson. And so if you have that code, you can go ahead and bring it up. And if you don't, you probably need to go back and watch lesson number 63, because that's where I showed you how to install Tensorflow Lite on the Raspberry Pi. But for now, what I will do is I will just show you how to find that code. You can go to the most excellent www.toptechboy.com, and then what I need you to do is search on something like Raspberry Pi lesson number 63. You can use this happy little search bar here, Raspberry Pi lesson number 63, and then you'll come, this is last week's video, and down here is the code we developed. Come over, click on the two page icons. You can copy that, and then you can come back over here to your Thonny on the Raspberry Pi. You can paste it, and now you are where we left off last week. But remember, if you didn't take last week's lesson, you got to go in and you got to install your libraries and configure your Pi to run TensorFlow Lite. Okay, let's just make sure that the universe is in proper working order, and let's see if we can run this code, and let's see if it still works. So I'm going to come in and I'm going to run, and let's see what happens. Boom, look at that. At about 6 or 7 frames a second, I'm finding a mouse, I'm finding a banana, scissors, keyboard, cup. Man, I am finding everything, even a keyboard way here in the background, finding me as a person, finding the bottle. Man, that is really incredible. And that's what we did last week. Well, if we could do that, why do we need to do anything else? Well, the way this works is we come down here and we set up in the first of the program, we set up our object detector, and then we come down here, and what we do is we pass our image to our object detector, and then we get this data structure back called detections. And detections has all of the things that were found, what was found, where they are, and what their label is, all of that data. The good news is this data structure detections has everything that we need. The bad news is it's a really gnarled up layer upon layer upon layer data structure, and if we want to understand it, we're going to have to go in and break into it. Now, why would we want to understand it if we can already do everything we want? Well, if you look at this, we take this data structure, detections, and we pass it to the library utils.visualize, and then it takes our original image and it puts the boxes on it, it puts the labels on it, it does all of that. Well, that's really neat. That's really a great thing, but what is the problem? The problem is, well, look at this. I consider that font to be unreadable. Maybe I don't like red boxes. Maybe I think the font is too faint and the box is too dominant. Maybe I don't want the font and the box to have the same color. Maybe I don't want it to decorate everything. I only want it to decorate the fruits and vegetables. Okay, you see, for us to go in and really start customizing this now, we need to not be using this utils.visualize. We need to take this detections apart, and we need to then get the data out of it, because we can draw rectangles in OpenCV and we can label in OpenCV and we can do all that sort of stuff, but we've got to have the data. So that's what we're going to do. We're going to try to bust into this data structure. Now, one of the challenges is this isn't just with TensorFlow. If you're doing MediaPipe, if you're doing TensorFlow, if you're doing all those different things, they tend to have complicated data structures. So I'm going to show you the approach I use to get to the bottom of it, to peel that onion, because a lot of times I find that the data structures are kind of like poorly documented, or the documentation is confusing and I don't understand it. So this is how I do it. The first thing I want to just do is I want to see if I can just print the data. So I'm just going to say print detections. That's what I just detected. I called it detections. I'm just going to see, can I print it? So I'm going to come in here and run. Hey, looked like it printed something. That's good news. Now, one thing I want you to see is, you see how we went from 7 frames per second. We're now down to something like 1 frame per second. The reason for that is print statements are very, very slow. And so because I put the print statement in, I killed my frames per second. That's okay, because we'll take the print statements out later after we understand the data structure. Now, one thing I can see is I don't know if this is just stacking them. I don't know where it begins and ends. So I'm going to come up here and I'm just going to print. I'm going to print just a blank line so I can see the data coming in individual detections. Okay, and so there we go, and now I'm going to quit. Okay, now I can kind of clearly see this is the break between the two different detections. And what is some good news as I just scan through this? Well, a good news is that I can see here that it has something called bounding box, and it's telling me the X origin, the Y origin, the width, and the height. So for this first object that it's found, the origin XY would be the upper left of the bounding box. And then if I take the X and I add the width, and I take the Y and add the height, I've got the bottom right of the bounding box, and voila, the information is there that I would need to put a box around that. Now, what you can also see is I've got the first bounding box, and then I have another bounding box, and another bounding box, and another bounding box. Why all those bounding boxes? Because I found a lot of different stuff. So it's giving me, in this one chunk of data, it's giving me the coordinates of all the bounding boxes. So that's information I need. What, excuse me, what other information does it give me? Well, it has this thing called categories. And then on categories, it is giving me like an index. And that's probably a number associated with different objects. And so maybe 0 with scissors or something like that. And it gives me a score. That's how confident it was it saw that item 0. The name is blank, but then the category name is person. So what we find is the index of 0 goes with the name person, and it was 81% sure that I was a person. That's pretty good. That's a pretty high score. I look a whole lot like a person. And believe me, that makes me feel good that I look like a person. Okay. And so what I have is I have the coordinates of the box, and then I have the name of what should go on the box, and I have the confidence that that is actually right. Then what is this? This would be the next object, which was the cup. Okay. Good news is it has everything that we need. The bad news is that it's inside of something called detection result, and then I've got something called detections, and then I've got something called detection, and then I've got something called bounding box, and then I've got something called bounding box. And so how would we take this data structure apart? Well, the first thing that I see is one of the outer layers of the onion. One of the outer layers of the onion is called detections, and also I called my whole data object detections, and that's going to be confusing. So I'm going to rename mine just my detects plural, okay? And then here I would print what? My detects, like that. And then what do I pass it here? I pass it my detects. Why did I do that? Just because as we're trying to peel back this onion, I don't want us to confuse this tag detections versus this one. So now they're two different words, just so it's really clear. Okay. Now I was able to print it, and what I see is this data structure has all the things that were found in the image. Now can I step through them? Sometimes you can get lucky, and the first thing that I just try is I'm just going to say for my detect singular in my detects plural, then could I just print the singular my detect? And a lot of times this will work, okay? And so what I'm hoping is by stepping through this, that it would automatically kind of give me these detections one at a time. It would give me these one at a time. And so I'm just going to see if I can do it that way. And so I'm going to come up and denied. It says detection result is not iterable. So that means that I've got this thing inside this outside wrapper called detection result. Okay. And so I've got to somehow get down inside this before I can really iterate. And so instead of iterating on my detects, that whole big thing, I'm going to try to iterate on my detect in my detects plural dot. Well, what is the first inside layer? It is this detections. And so I'm going to try that. Okay, so I'm going to step through detections, and then hopefully it will sort of start giving me little chunks of data like that. And so now, again, I'm going to print my detect. And so let's see what happens. We're going to run it. Okay, it's running. And now let's look. Okay, that looks pretty good, but I'm gonna put that print statement in just so I can sort of see those chunks of data coming in. Okay, so I'm going to come in and run it. Okay, now look, this print statement, now my detect is this, and that looks like a lot cleaner. That looks like a lot cleaner little bit of data. Okay, so now let's see if I can go in for this now, this my detect, which is this. Let's see if I can go in and get some of that data that I want. So let's say, what if I said print, and I'm going to print my detect, okay, and that's the singular, right? And now what if I try to get into this bounding box with a dot bounding box? And now what if I try to get in and get this origin X? So then I'm going to say dot origin underscore X. And let's see if I can just get that X value there. And what if we try to get X comma Y? So I'm going to go copy and then paste and X comma Y. So do you see why I'm saying we're peeling the onion? That I got down to this nice data structure. Now I'm going dot bounding box, and then I'm going dot origin X to try to get to these things inside here. So now let's run this and see what happens. Okay, look at that. What do I really like? I think this is the X, Y coordinate of the upper left bounding box for the bottle. Okay, and that is actually very useful. And so what would that be? That would be the upper left. I'm going to go ahead and create a variable upper left. Okay, and that is going to be, upper left is going to be equal to this tuple, and I'll just grab it up here because I just produced it. Now I want to put it in this variable, this tuple variable, upper left. Okay, now why don't we go ahead and say the lower right would be equal to, let's paste that again. Okay, but now what do I need to do to the X? I need to add the width. Okay, I need to add the width. And so that would be, lower right would be, I was going to add the my detect dot bounding, my detect dot bounding box, my detect dot bounding box dot width. Okay, and now on the Y over here, origin Y, I need to add the what? The my detect dot bounding box dot what? Height. Okay, now let's see if we can print. I'm not going to print this one anymore because I don't need it, but what I'm going to print now is, what if I just print, and I print, I do need that. I don't need to print it there. Okay, now what if I just printed the 2 points, the upper left and the lower right of the bounding box? Okay, now let's do that. Okay, look at that. All right, so what I'm getting is I'm getting the corners of the rectangle for the book, the corners of the rectangle for the keyboard, and so we're down to we got some useful information here. All right, now I could draw the box. In fact, let's go ahead and let's see if we could draw that box on there. Okay, so what would I do? I would do an image. Is that what I called the original image? The original image is called IM. Okay, so now I want to put a box on image. I'm going to say IM is equal to CV2 dot rectangle, CV2 dot rectangle. Okay. And then what do I want to put it on? I want to put it on the image. And then what do I want to put there? I want to put it at the location, the upper left, which I know, and the lower right, which I know. And then what else am I going to need? I'm going to need a color and a weight. And so I think I'm going to go on up here and I'm going to put in variable. Okay, and I've got some variables there for the frames per second, but now I'm going to put box color, and let's make it blue. So I'm going to make it 255, 0, 0. Okay, and then I'll put box weight is going to be equal to, let's make it 2. Okay, now when we come down here, it'll be easy to draw our rectangle. So I'm just going to now say, I'm now going to say box color and box weight. Okay, now also, since I'm doing the heavy lifting now, I'm not going to have it decorate the image. So I'm going to take that out. And now this time I think we should just have frames per second and blue boxes if I'm thinking about this right. Wow, look at that. Look at that. That is absolutely spectacular. Okay, now I like the blue boxes and I like how heavy they are, but what have I not done? I haven't put the label on there. Okay, I haven't put the label on there. And so let's see, what I'm going to do now is I'm going to need to figure out how to get this label name. Okay, I'm going to have to figure out how to get the label name. And so I'm going to come in here and before I do the rectangle, I'm going to come in and see if I can get that. And so let's say if I just say print, and let's say I have my detect, and then now instead of bounding box, right, instead of this bounding box, what I want is I want categories. Okay, so I want categories. So my detect dot categories. Okay, and then what do I want? I want the dot category name. Categories dot category underscore name, like that. Okay, now close that. Let's see if I can go snag this thing now that'll just print that out. Okay, so we're going to come in and we are denied. Okay, it says that in line 63, okay, list object has no attribute category name. All right, now why was I able to, let's see, why was I able to do a dot? I was able to do a dot bounding box dot origin, but I can't do a categories dot category name. And so let's look at this. When I am doing the detections, okay, then it just opens directly. You see, it has like bounding box is equal to what we have, you know, the bounding box. But on categories, it opens another array. So you see here, bounding box just goes directly into this bounding box. This categories is creating an array. Okay, now the array only has one element. The array only has one element, but yet it creates this array. So you see, I want you to understand this. On bounding box equals, it goes directly into this next layer. Categories doesn't go directly into the next layer. It creates an array. And maybe that's because, like, if you had something, it might have different labels for the same object, like boat, canoe, and something else. Maybe you could have multiple labels for the same object. But anyway, there's an extra layer to the onion. Well, since I only want one name, I'll take the first name, and so the way I get rid of that here is at the categories level, it's an array, and so I'm going to take the 0th element, like that. And why am I taking the 0th element? To bust past, and you have not been seeing that, have you? I'm sorry. Let me get further out of your way. Okay, I want to bust into, it is this parenthesis that is causing me the problem, and I want to bust into that. And the way I bust into that is to come up here and say a category 0. And again, just to be clear, that when I have bounding box, it goes directly into bounding box. When I have categories, then it puts this open. And the way I get into that open is by putting an index here. And this actually happens pretty frequently in these artificial intelligence data structures, that they're not symmetric, that when you have this huge data structure, this part of it has 2 layers to the onion and this part has 3 layers, and you can use an index here to kind of deal with that. And I really hope you were able to follow it, even though my head was in the way. That you can see it is this bracket right here that caused the problem, and so I dealt with it by putting an index here. Now let's see if it will print what we have when we step through here. Okay, so I'm going to come in and I'm going to go quit like this, and look at this. So it tells me that I have a mouse and it tells me where it is. So at this point I have everything that I need to what? Not just draw the rectangle, but to put the bounding box. I mean, not just draw the rectangle, but to put the label. So I'm going to do cv2.putText. Okay, cv2.putText. Where do I want to put it? On the image. And then what do I want to put there? I want to put the object name. And how am I going to get that? Well, here I don't need this print statement anymore, and I can just say object name. Object name is going to be equal to my detect.categories index 0 and then category name. Okay, and then where is that category name? That would be, so I've got, like, you know, just to be clear, I've got the dot categories here, and then index 0 that will give me this chunk, and then dot category name, which will give me what? Bottle. Okay, so now I'm going to do that. And now where am I going to put it? I'm going to put it at the upper left. I've already got that. And then what am I going to do? I need what else? I need a font, and I've labeled my font up there. I want label height, label color, and label weight. W-E-I-G-H-T, like that. Now let's see if we've defined those. I think I've done font, but I don't know if I've done label, label, label. But if I come up here, okay, if I come up here, I have defined a font, but then I didn't specifically do the things for the label. So what was it? It was label height, not Babel, label height, and let's make that 1.5. Okay, let's go label color. Let's make the color green, so that would be 0, 255, 0. We can change that in a minute. And then label weight is going to be equal to, let's make it 2. Okay, what do you think about that? Do you think that would be good? Label weight 2, label height 1.5. I'm not sure if that'll take a float. It'll crash if it doesn't. But you see, this way, if you set it in parameters up here to edit the program later, you don't have to remember. If I just have all these numbers, I'm not going to remember what order they were in. Okay, I'm not going to remember what order they were in. But let's run this now and see what happens. Label color. I thought I just defined that. What is that nonsense? Need the old equal sign in there. All right, let's try it again. Object name. Man, I'm just falling apart here. What did I do wrong? Oh, I lost my O. Object name. Okay. Okay, look at that. Bottle, keyboard, banana, cup, scissors. Man, that is pretty neat. Okay, what do I want to do now? I want to get my frames per second back up. So the way that I'm going to do that, I'm going to take this print statement out because I've already got the data. I don't need to print it. I just needed to print it so I could kind of figure out what it was. Okay, and now I think I've taken all the prints out. Let's see if we can get back up to 6 or 7 frames per second here, hopefully. I still have one print in there. Where did that print There it is. I'm confident in those, so I'm just going to take them out. All right, now let's try it. I need to get out of your way. Okay, let's see what we can come up to. I'm not printing anything. The frames per second is coming on up to 4 and 5. And look at that. Can you not see that this is much more readable than the earlier one? Look at that. Mouse, scissor, keyboard, banana, bottle, cup, person. And that is just really looking good. And I'm sitting here at 4 or 5 frames per second. Now, it could be that when I'm doing this in OpenCV, maybe I'm not doing it perfectly efficiently, and it seems like it has slowed down a little bit by doing it my way, but still I like this because now I have control of things. What do you think? You guys tell me. You guys leave me some feedback. This has been a tedious lesson, but did you see what I'm trying to show you how to do? I'm trying to show you how to take a really complicated data structure and then come in and break it apart and get the useful information out of it. And I hope that kind of makes sense. And I'm kind of looking here and see, did I really slow it down? Let's see, I'm going to come in and I'm going to just comment all of this out. So I'm going to say toggle comment. And then I'm going to go back and do it where it just does everything for me. Okay, here having it do everything for me. It's still operating a little slower. So I'm not sure why it's operating slower now than what it was when we first started, because I've taken out all the print statements. And so I guess it just could be because of the busyness of the issue, the busyness of the image. But it seems like whether I do it with their detection or their decoration here or my decoration, it's all operating at about the same speed. And so that's actually kind of good in my mind. And so let me come in and edit, toggle line comment. Now we've got our thing working again. And I'm just looking in here to make sure I didn't do anything else that would have slowed it down. And I can't see anything that I did that would have slowed it down, but we're going to come in. Okay, that is pretty neat, and it's coming on up to, maybe we'll get to 4 or 5 frames per second, and that would be really good. So let's quit. Now, what could we do? We could do something like on this decoration business where I am in here, and I am doing the put text, and this, what I could say is, if object name equal banana, if object name equal banana, then what I would do is I would do this and I would do this, and then on the rectangle on box weight I would make that a -1. And now tell me what this is going to do. Somebody tell me what this is going to do. We come in, and what have we done? We've created a program that masks out all bananas in the picture. And in that case, actually, I think I would probably not want to label the hidden object, because maybe I just want to take the hidden object out of the picture. Okay, so we've got a banana blanking program here. And then if I get the banana and move it, okay, I get the banana and move it, it takes a second to find it again. So we would want to tune in on the banana a little bit better, because you can see that it's not finding it perfectly every time. Maybe we would change the confidence values there or something. But you can see what we've done is we've got a banana blanking artificial intelligence programs. Maybe if somebody was afraid of sharp objects, you could not trigger them by taking all the scissors out of the pictures. But is that pretty neat? I'm still curious. This thing seemed to, as we went along, it seemed to slow down. Maybe what if we said change the max number of objects to 4 might help. And then if we came in and we made the image smaller, let's see if I went 640 by 360. Come in and run it. Still kind of slow. Maybe I need to reboot or something. Something in here. Maybe I had a little memory leak or something. But it's just interesting that we went from about 7 frames per second when the video started, and now we're down to 4 frames per second. So I'll try to look into that a little bit and see if I can better understand what's going on. It's not blank. Yeah, there it is. It's pretty much doing what we would expect there. Okay, so let's talk about your homework for next week. First of all, your homework is to just come in. Your homework is to come in and get working what I just showed you. And now what your homework assignment is, and let's see if I can show. I might have to come in and run the program again to show you. But most of you guys that are taking the class have the pan tilt hat, right? And so you can see my little Raspberry Pi here. Let me come in and make this big again. 1280 by 720. I'm going to save this. I'm just curious. I'm just so curious why this thing was going so fast to like half the speed. I wonder, okay, I saved this. It's saved. I'm going to close this. Let's close. I wonder if I just open up Thonny again. I'm wondering if it'll kind of clear something out. I'll play around with this after the video and try to figure out. I'm sure if I reboot, it'll go back to running fast. Okay, I might need to reboot it to get my speeds back up. But anyway, what you see here is you see the pan tilt hat that we have for the Raspberry Pi. And so what your assignment is to figure out an object of interest. Maybe your object of interest would be a banana, and then to track on your object of interest where your pan tilt bracket is tracking the object of interest, which could be a banana, or it could be scissors, or it could be whatever. But you would track on an object of interest with the pan tilt hat. Okay, guys, that is where we are right now. I hope you guys are having as much fun taking this class as I am making the classes. I really had a lot of fun doing this particular project on the Raspberry Pi. I hope you're enjoying it too. We're probably going to spend another couple of lessons on just some general artificial intelligence stuff that you can do on the Raspberry Pi. And what you can see is that it is not blindingly fast, but if you were going to do this on something like the NVIDIA Jetson Nano, the software would really, man, I lost my image back there. I don't know. Hopefully it'll come back. The river cam is gone a little off on me. Okay, if the river cam isn't going to cooperate, we'll look at my front yard. You can see that I put in a corn patch. I'm basically taking out all of that grass and I'm putting in things that you can eat. And because the grass is just a huge amount of fuel and a huge amount of effort to keep it mowed, and so I'm going to put in more, expanding our little organic farm there. But that's what we've got going in the background. But I hope you guys are enjoying these lessons. If you enjoyed the lesson, give us a thumbs up. Also, it helps us with the old YouTube juice if you will leave a comment down below. If you've not subscribed to the channel already, make sure that you subscribe. And when you do, ring that bell, because that will allow you to get notifications when future lessons drop. And as always, most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.